Hi, I'm going to show you how to observe the RF carrier on a scope. Now, we were talking about this on the forum, but what I'm having to use here is the little pantry transmitter. This is a test one that I made up some time ago. It's quite handy. So the scope input is actually connected to the RF output of the pantry transmitter, and it goes to the input of the scope. At the moment, the gain is set to 0.5, but that's arbitrary because at the moment we've got a fair signal here. And the time base is run at 0.2. The trigger is going back to the audio input so as we can sync it up to the audio. Okay, well that's the RF carrier. Now what I'll do is I'll put on a bit of signal. Now at the moment I'm going to put on a sine wave, which is running at 1 kilohertz. So if I turn up the level, we can see this is what we would normally expect to see on the scope. Now it clips a little bit. This is unfortunately this is just a bit too high for it. But as we turn it up, you'll see that the middle disappears, right? And it turns into a line and the whole thing gets crushed, right? Don't worry about the V's on the top and bottom of the signal. That's not what we're looking for. That's just a facet of this little transmitter, and I think one of the batteries is a bit low, to be fair. So there you go. That's what we would see. Now if we put an audio signal into it, we'll eject this particular disc and we'll put in another mini disc with music on it. This will give you an idea of what to look for on your radio. And I'll tell you where to put all the probes and that after. There we go. Now, this is, you may actually have to turn the time base down. I find it's better around about 1 millisecond, right? This is what you would be expecting to see under normal circumstances, right? But if it's over modulating, you'll notice that there's those lines in the middle where there's nothing there. That's just, you actually lose the carrier. So this is what you'd be looking for on a station that's over modulating. Plus, of course, you would notice that the tops and bottom of the waveform is actually flat as well. That's it sped up a wee bit. That might be a bit easier for you to see. But you do see the centre parts that are actually missing, you know. And as I say, the top of the waveform looks very flat. You may be able to slow it right down and see it maybe better. But the thing to look for is those lines in the middle. That's wrong. That shouldn't be like that. If you reduce the input, you'll see they gradually disappear like that. They're not there now. And that's what you should be looking for. Okay, now the ideal is use your trigger from the speaker, right? So you can sync the scope up. Your input, you can put it to the hexode section of your ECH35, which I believe is anode hexode is pin 123. Okay. Or you could put it on the top cap of the EF39, the IF amplifier. You probably will need to increase the gain on the scope, which is this one, you know, volts per division. You know, as you can see, the gain goes up. So basically you can see it. It depends on the signal level from your station, but that's the basic way of trying to do this. If you see this flat-topped part of the signal and the lines in the middle, the station's overloading. The set itself cannot cause that particular problem. It's just coming in like that. And to be fair, if you do have that problem, I would suggest you contact them, because an overmodulating transmitter will produce a lot of sideband splatter and harmonics, and that's not allowed by Ofcom. Okie doke. Thank you. Bye.